Hi, I'm Percival.
Hi, I'm Charlene.
Hi, I'm Mariane.
And I'm weak nuclear force Wilson.
Today's lab is on
Hess Law!
The foundation of the study of thermochemistry was laid by the chemist Germain Hess. One of the statements of the laws that bears his name says, "The enthalpy change for any reaction depends on the products and reactants and is independent of the pathway or the number of steps between the reactant and the product." In this experiment, you will measure and compare the quantity of heat involved in 3 reactions. The heats of reactions will be measured using a styrofoam calorimeter.
In the first reaction, we will observe the dissolving of solid sodium hydroxide in water.
The second reaction, we will observe how solid sodium hydroxide reacts with dilute hydrochloric acid.
In the third reaction, we will observe sodium hydroxide solutions with the dilute hydrochloric acid solution.
The objective of this lab is to measure and compare the amount of heat involved in 3 separate but related reactions. And the second objective is to provide experimental verification of Hess's law.
For materials and apparatus, you're going to need safety goggles. One of the most important things while conducting a lab. You will have to keep these on during all times or else your teacher will deduct marks. Next, you will need a 250 milliliter styrofoam cup. Secondly, you will need 3 100 milliliter graduated cylinders.
You will also need solid sodium hydroxide and 0.25 mole HCl, as well as 0.5 mole NaOH and 0.5 mole HCl.
Next, you will need 2 thermometers and also a balance to measure your solid sodium hydroxide.
And finally, you'll need a 250 milliliter beaker and a metal scrupula for handling the NaOH.
Safety first!
Always remember that hydrochloric acid and sodium hydroxide are highly corrosive.
Corrosive.
So avoid direct contact.
If it does touch your skin, wash it off immediately.
Remember to always handle your solid sodium hydroxide with a scrupula because it reacts rapidly with the air. And make sure to always cover the solid sodium hydroxide once you are finished with it.
After you're done, make sure you throw out all of your solutions and acids properly with the help of your teacher.
So for this first reaction, you're going to need 200 milliliters of cool tap water. Remember when measuring the water in the graduated cylinders to always measure from the bottom of the meniscus at eye level. It doesn't exactly have to be 200 milliliters, but whatever amount of water you take, record that. So you take the graduated cylinders and you pour the water into your styrofoam cup calorimeter. Then you take your thermometer and you stir the water in the cup until it reaches a constant temperature. Then you record the temperature of this water.
Now you'll take your solid sodium hydroxide and measure it on your balance. Make sure that the screen is set to 0 and that you have a piece of a paper towel in order to avoid direct contact with it. You will have to try to measure as close to 2 grams as possible. Now you'll take your measured solid sodium hydroxide and drop it into your water. Using the thermometer, you will now stir until the pellets are completely dissolved. And once you continue stirring, you will need to measure the maximum temperature at which your thermometer reads.
So after performing this part of the experiment, discard the solution safely into the sink and then rinse the cup thoroughly with water.
So now, you're going to take your styrofoam cup and fill it up with 200 milliliters of 0.25 moles per liter hydrochloric acid solution.
For your lab, your teacher will have prepared for you 0.25 moles per liter hydrochloric acid. Now remember to pour your solution from stock into a smaller beaker. Next, you'll pour the amount of solution from your beaker into the graduated cylinder. Pouring solution from the stock beaker into a smaller beaker prevents contamination and wasting solution.
So remember, you're not going to have exactly 200 milliliters, but when you do have your HCl solution, make sure you measure from the bottom of the meniscus and record what you have. Then you pour this into your calorimeter. Then you take your thermometer and you stir the solution until it reaches a constant temperature. Then you record the temperature of the solution.
Now you'll take your solid sodium hydroxide again and take 2 grams and measure it again on your balance. Make sure to set the balance to 0. Make sure to always put the cover back on the solid sodium hydroxide. Now you'll take your measured amount of solid sodium hydroxide and pour it into your solution. Stir again until all the pellets are dissolved. And then measure the highest temperature that your thermometer reaches.
For this part of the lab, you'll have 0.5 moles per liter sodium hydroxide and 0.5 moles per liter hydrochloric acid. Now remember, when you're pouring your solutions, pour from the stock beaker into a smaller beaker, approximately 100 milliliters. This method prevents contamination over an excess use of the solution. Next, you'll pour 100 milliliters from your smaller beaker into the graduated cylinder.
Make sure when measuring 100 milliliters, you measure from the bottom of the meniscus, and it doesn't have to be exact as long as you record whatever quantity you have.
Next, you'll pour your 100 milliliters of hydrochloric acid into your cup calorimeter. Then stir the solution with a thermometer and record its temperature.
Now you're going to take your 100 milliliters of 0.5 moles per liter NaOH and pour it into a beaker. Then you will stir it and record the temperature of the solution. Now from the beaker, you're going to pour your NaOH into your HCl solution in the cup.
Then you'll stir the solution and record the maximum temperature of the reaction.
If you get any NaOH or HCl in your hands, make sure you wash immediately.
After this experiment, discard the solution properly and then rinse the cup.
From your data, you'll calculate the following from each experiment. The accepted value for the heat of solution of sodium hydroxide can be found in your chemistry textbook. Compare your experimental value with this accepted one and calculate the experimental error. Experiments conducted today all demonstrated exothermic reactions.
And all embody Hess's law. For a copy of this lab, click this link up here.
Down here. No, it's not.
No, it's
over
pretty
there.
up there.
I'm pretty
Here.
sure.
Guys, I'm pretty serious. It's up here.
Pretty serious?
No.
I hope you guys had fun today and you learned a lot.
Stay safe. And keep these goggles on.
Don't try it at home.
Whatchamacallits.
Please. Make sure when cleaning up your workplace to pour all solutions down the sink and with them a lot of water.
Also, wash all beakers and cylinders with soap and water.
hydroxide with a scupula because it reacts. Okay, wait.
Wow.
Okay, hydrochloric acid and sodium hydroxide.
And I say when you say corrosive, it's like corrosive.
Hydroxide, the scupula, because it reacts.
Oh, that was so good too.
I can't say
You never
it.
become an actor, Mary.
Part 1. The dissolving of sodium. Screw that. Okay, you're doing it.
Okay.
I prepared for you 0.25 moles per liter sodium hydroxide acid solution.
Wow. Okay.
That's so easy, isn't it, PJ?
For your lab,
Now pour your. Okay, wait. What am I pouring? Hydrochloric. Okay, so hydrochloric acid.
The bottom of the meniscus and record what you have.
Charlene can do that.
What? Say that?
Okay, this is perfect for me.
What did I say? Okay.
But it's okay.
okay, who's first? Me?
You.
Hi, I'm Percival.
Why can't you?
That's my name.
We don't want to know your name.
Didn't you say you wanted to show this to your kids?
Yeah, Percival. Percival. Okay, start
Is
again.
that what
start again.
PJ stands for?
Yeah, Percival.
It's Percival John.
Really?
Yeah.
I thought you were making that up. Sorry.
No, I'm serious. Oh, wow.
Sorry, no
Wow,
offense.
what is
I
this?
didn't know. I didn't know. I just knew you as PJ.
Great. I'm sorry, kids.
The products and reactants as is.
Same spot.
There's too many words.
As,
Sir, leave.
and-
It's not your fault. If you want, yeah, do whatever you want to do. Make sure there are no chemicals to spill.
It's like, yay, acid.
And if you want room, you can move the desks and
Pop and Bob.
No.
And then drink out the.
Oh no.
Hey, which one is
It's
it?
getting hot in here, so take off all your coats. I am getting so hot. I'm gonna take my coat off.
Which one?
Oh, it says chemistry.
I know. But which,
But the levels are up here. So each of these reactions released energy in the form of heat. A reaction that releases heat is known as an exothermic reaction.